In this video, we are going to delve into the concept of exact differential equations. We will start by outlining the objectives for today's session. We will be exploring the basic concept of exact equations. We will also be testing for exactness. We will delve into the concept of integrating factor, and this will culminate in easy steps for solving exact differential equations. Before we proceed, I'd like you to understand this. Solving an exact differential equation involves verifying the exactness condition, finding the potential function, and using it to determine the solution. With practice, this method becomes a powerful tool for tackling differential equations. A differential equation of the type m of xy dx plus n of xy dy equals to 0 is called an exact differential equation if there exists a function of two variables f of xy with continuous partial derivatives such that the derivative of the function is equal to m of xy dx plus n of xy dy. The general solution is usually given by f of xy equals to c, where our c is a constant. Let the function m of xy and n of xy have continuous partial derivatives in a certain domain. The differential equation m of xy dx plus n of xy dy equals to 0 is an exact equation if and only if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x, as shown. Then we can simply write that as my equals to nx. When solving exact differential equations, you have to apply the above formula in testing if the differential equation is actually exact. We are going to delve into the concept of integrating factor. If the differential equation m of xy dx plus n of xy dy is equal to 0 is not exact, it can be made precise by multiplying it with a relevant factor known as the integrating factor for the given differential equation. You are going to appreciate this concept when we will be solving a lot of problems. Now, how do we solve problems on exact differential equations? What are the rules? What are the easy steps to apply when solving exact differential equation? First of all, you have to identify the exact equation. Recall, an exact differential equation is generally written in the form m of xy dx plus n of xy dy equals to 0. You have to understand that for the equation to be exact, it must satisfy the condition that the partial derivative of m with respect to y has to be equal to the partial derivative of n with respect to x. Moving forward, you are going to verify the exactness. To verify if the given equation is exact, you have to calculate the partial derivatives of m with respect to y and that of n with respect to x. You are going to find the potential function f of xy that satisfies the conditions and solve for the solution. Now let's start by looking at an example in the next video where we will deploy all these rules in solving a lot of problems. Do well to like and subscribe to my channel. Thank you.